Dear students, in this video, I will give you a brief idea about what is Harvard architecture and similarly what is von Neumann architecture. So at the end of the video, you may get idea about what is Harvard architecture and what is von Neumann architecture. So let's see detailedly. So first coming to von Neumann architecture. Okay, so it is invented by John von Neumann in the year 1945. He's a famous mathematician. Okay, that's why name comes like a von Neumann architecture. Okay, so if you see the diagram once, see here we have main memory system. Okay, then central processing unit, then input and output system. Okay, coming to main memory system, here both ROM memory, RAM memory, nothing but what the other name of ROM memory? It's a program memory. RAM memory called as a data memory. So both ROM memory and RAM memory, it's act like a single memory here. And here we can access both program memory as well as ROM memory, only one memory at a time. Means we have one single set of system bus. So single system bus is available. What is system bus? It's a combination of data bus, address bus and control bus. So we have only one single set of system bus is available, and we can select either data memory or instruction memory. See, let's see data memory also called as a RAM memory, instruction memory or code memory or also called as a ROM memory. All are same. So instruction memory, code memory, ROM memory same. Means we can select either data memory or instruction memory, one memory at a time, because of these two memories are making like a single memory. So we can take either only one memory at a time. Means only one set of buses are there, and with the help of these buses, we can select either ROM or RAM, one memory at a time. Okay, this is the main limitation of von Neumann structure. And remaining part, like a central processing unit, nothing but it's a processor, where we have three main units are there. One is called as ALU, that is arithmetic and logical unit. Other is called as control unit, and other is called as register arrays are there. And every time processor may take input from the external input device, perform the required operation, and result will be sent to either output device or memory device with the help of all the units present in the central processing unit. Okay, this is the main issue related to von Neumann structure, where we have single memory for both data operation as well as code operation, and one set of bus is available. So let's see other one, Harvard architecture. See same again, von Neumann. Here you may observe program memory and data memory. Both are communicated to processor and both are like a single memory only. Coming to Harvard architecture, here we have separate program memories available and separate data memories available, and separately we have system bus for program memory and separately we have system bus for data memories also available. Okay, so again here if you observe program memory means it's a ROM memory, data memory means RAM memory. Separately we have ROM memory and RAM memory. So in case of Harvard architecture, we have separately ROM memory is available and separately RAM memory is available, and ROM is connected to processor with the help of separate system bus, and RAM also connected to processor separately. We have system bus. Okay, so because of two separate memories, so if you want, we can access ROM memory. Similarly, if you want, we can access RAM memory at a time. That provision is there in the Harvard architecture, not there in the von Neumann architecture. It's the basic difference. And if you see here, von Neumann, the basic Harvard architecture, here if you see, there is a main memory system where we have separate data we can select, and separate instruction also we can select. Nothing but data selection separately code memory selection also possible, and separately data address bus is there, and separately instruction address bus is there. Remaining parts same, like central processing unit, where ALU, control unit, registers, anyway they are same. So only thing is here we have separate system buses are there for data memory as well as for the instruction memory. Okay. So because of that, this Harvard architecture is having advantage. We have two separate buses are there, one for instruction and one for data. Okay, and we can perform the operation also little bit quick. That's why this type of architecture is used in the 8086 and even ARM related process. Coming to the comparison between von Neumann architecture and Harvard architecture. So let's see, it's a von Neumann architecture I already mentioned. It's based on stored program computer concept. Whereas here modern computer architecture related concept in case of Harvard architecture. Here same physical memory address is used for both data memory as well as for the instruction memory. Nothing but RAM and ROM both are using the same location. Here separate physical memory is available for both data memory as well as program memory here. Okay, so here it's a common bus for data and instruction, whereas here separate buses are there for data operation purpose and instruction operation purpose. Here it requires only an instruction is executed in a single clock. Within one clock, we can execute the instructions. Here, more than one clock required, maybe two clock cycles, or sometimes more than that also required to perform the operation. Here it is a cheaper in cost, whereas one compared to Von Neumann, Harvard architecture is somewhat costlier because of separate arrangements. Okay, here one more CPU can access instructions and at it and even read and write at a time. Means I already mentioned CPU can perform either data or instruction one at a time. Whereas here separate CPU can perform both operations at a time. Means we can perform instruction operation or we can perform data operation at a time. It is used in the personal computers and small computers only comes under this Von Neumann architecture. Whereas like microcontrollers, signal processing related applications, we use Harvard architecture because of two operations we can perform at a time. Okay, so this is about Von Neumann architecture as well as Harvard architecture. Okay.